Good day, everyone. I'm Captain Ron Irani, and very soon I will be taking a class. But before I begin a class, I have a social message for every one of you. Please do wear a mask at all times. Please wash your hands frequently. Please avoid crowded areas. Please stay at least 2 meters away from others. And most importantly, get yourself and your family members vaccinated. It definitely works in controlling the spread of the coronavirus. At the end of the class, do give a thumbs up, subscribe to my channel, as well as click on the bell icon to get instant notifications as soon as something new is posted on my channel. In this class, I'm going to talk about how to calculate areas and volumes using Simpson's rules. Now, Simpson's first rule for areas using breadths or half breadths and volumes using heights or drafts. The picture on the left hand side, here we are using three half ordinates y by 2, and those ordinates have been named A, B and C. They divide the shape into two sections, each being h meters apart. And the Simpsons multipliers that we are going to use are 1, 4 and 1. We can use the full ordinates, that is y, going from one end to the other end of the shape for each of them, or we can use half ordinates. But when we use half ordinates, the final result that we get will have to be multiplied by 2. Now, in case we are using 5 half ordinates, A, B, C, D and E, we will have 4 sections, as you can see in the picture in the drawing down here. And the sections multipliers that we use here are 1, 4, 2, 4 and 1. Now each of these half ordinates are h meters apart. So coming to the first rule once again, areas or volumes 2 times the formula being for Simpson's rules 1 by 3 into h into the sum of the products. And why is it 2? As I mentioned earlier, is because we are using half ordinates. If we are using full ordinates, we do not have to multiply it by 2. And this is basically for odd number of half ordinates or full ordinates. Going on to the next slide, I will explain how we come across, how we can compute this as 1, 4, 2, 4 and 1 when we have more than 3 ordinates, odd numbered ordinates. Here we have 5 half ordinates, y by 2, A, B, C, D and E, as you saw in the previous slide. Each of these ordinates are h meters apart, thus giving us 4 sections. And how do we arrive at the multipliers 1, 4, 2, 4 and 1 is what I'm going to explain over here. Now let us take the area A, B and C. Okay. Since they are half ordinates, we have to multiply it by 2 to get the full area. And the Simpsons first rule formula is 1 by 3 into h into the sum of the products, that is A into 1, B into 4 and C multiplied by 1, 1, 4, 1. Okay, just for A, B and C, half ordinates. Now we take the area C, D and E. Okay. Here also we repeat the same formula with the ordinates with the multipliers being 1, 4 and 1. So once again 2 times 1 by 3 into h, where h is the distance between each of the ordinates. And here we have c multiplied by 1 plus d multiplied by 4 plus e multiplied by 1. So once again we have 1, 4 and 1. That is the basic formula for basic multipliers for Simpson's rules. First rule. Now we add the two. Since we want the whole area going from A, B, C, D and E, and as we had divided it into two parts, A, B and C, and the other part being C, D and E, we have to add both of them. So what do we see? If we take it for the area A, B, C, D and E, we have 2 times 1 by 3 multiplied by h, which is the common thing in both the equations on the top. Into brackets, we have a multiplied by 1 plus b multiplied by 4 plus c multiplied by 2. We are adding them, c multiplied by 1 plus c multiplied by 1. Thus we have c multiplied by 2 plus d multiplied by 4 and plus e multiplied by 1. Thus you can see that the Simpsons multipliers have changed from 1, 4, 1 for 3 ordinates or semi-ordinates to becoming 1, 4, 2, 4, 1 when we have 5 ordinates. In case we had 7 ordinates, it would be 1, 4, 2, 4, 2, 4, 1. And the list goes on. We come to the full ordinates now. Simpson's rule 1 for full ordinates. Now, for being full ordinates, we say just y. We call them y. The same rules apply. The same multipliers apply, 1, 4 and 1 when we have just 3 ordinates. And the same multipliers apply when we have 5, 7, 9 ordinates. If it was 5 ordinates, as I showed you earlier for semi-ordinates, the multipliers are 1, 4, 2, 4, 1. If there were 7 ordinates, it would be 1, 4, 2, 4, 2, 4, 1. Here, if you look down below, as per the first rule, areas and volumes, since we are using full ordinates, we do not multiply it by 2. It is just 1 upon 3 multiplied by h multiplied by the sum of the products. And this is also for odd number of full ordinates. Simpson's second rule for areas and volumes using half breadths or full breadths and heights or drafts. The drawing on the left hand side, we are using 4 half ordinates. And since they are half ordinates, we denote it as y by 2. And the half ordinates are A, B, C and D, thus giving us 3 sections, each section being h meters apart. The Simpsons multipliers that we use are 1, 3, 3, 1. If we had 7 ordinates or 7 half ordinates, A, B, C, D, E, F and G, we would have 6 sections. And each of these ordinates would be h meters apart. The Simpsons multipliers, however, we would be using are 1, 3, 3, 2, 3, 3, 1. The Simpsons' second rule formula is, since we have used half ordinates, we multiply it by 2. The basic formula is 3 upon 8 multiplied by h multiplied by the sum of the products. Now this can be used for odd or even number of half ordinates or full ordinates, but they have to be in this order: 4 or 7 or 10 or 13 or 16, and it progresses in that fashion. Now, how do we come to this conclusion that it will be 1, 3, 3, 2, 3, 3, 1 when we have more than 4 ordinates, that is, where you have 7 ordinates? I will take you back over there to the next slide. We have 7 ordinates: A, B, C, D, E, F, and G, each of them being h meters apart. And how do we come to be using 1, 3, 3, 2, 3, 3, 1 as Simpson's multipliers? This is what I'm going to show you now. So let us say you have to calculate the area between A, B, and D. The total area between A, B, C, and D half ordinates. The basic formula, Simpson's second rule, is 2 times, because we are using half ordinates, 3 upon 8 into h into A multiplied by 1 plus B multiplied by 3 plus C multiplied by 3 plus D multiplied by 1. And now if you have to calculate the area between the semi-ordinates D, E, F, and G, it would be 2 times 3 by 8 multiplied by h multiplied by D multiplied by 1 plus E multiplied by 3 plus F multiplied by 3 plus G multiplied by 1. And if we add up all of that, we would get the area between all the ordinates A, B, C, D, E, F, and G, 2 times, because we have used half ordinates, and the Simpson's formula is 3 upon 8 multiplied by h multiplied by, into bracket, 8 multiplied by 1 plus B multiplied by 3 plus C multiplied by 3. Now we have D multiplied by 1 on top and D multiplied by 1 at the bottom. Thus we have, when we add it up, D multiplied by 2 plus E multiplied by 3 plus F multiplied by 3 plus G multiplied by 1. Thus you see how we got the Simpson's multipliers for second rule as 1, 3, 3, 2, 3, 3, 1. What if you had used 10 ordinates? What if you had 10 ordinates? What would the multipliers be? It would be 1, 3, 3, 2, 3, 3, 2, 3, 3, 1. You can prove this by yourself using the same method that I have shown over here. Nothing changes if you are using full ordinates, except that you do not have to multiply it by 2 over here. The multipliers stay the same, 1, 3, 3, 1 for 4 or full ordinates, and for 7 ordinates they also stay the same, 1, 3, 3, 2, 3, 3, 1. But the only thing is, when you are calculating the total area, you do not have to multiply it by 2 because you have used full ordinates. Moving on to Simpson's third rule. We need to find the area between the ordinates D and E. And we have half ordinates, in this case C, D, and E. If we have to find the area between the ordinates D and E, we need to work backwards, that is from right to the left. We have 2 sections between the ordinates C, D, and E, or let me say E, D, and C. Each of those sections are h meters apart, and the multipliers that we will use are 5, 8, and minus 1. Now in the picture on the right, in the drawing on the right, we have to find the area between the ordinates D and E. We can use the ordinates or semi-ordinates D, E and F also. Just as over here on the picture on the drawing on the left, we use the ordinates C, D and E. We could have over here also use D, E and F. So this is just an example as to what you can use. You are free to use whichever one. However, the formula is, for Simpson's third rule, since we are using half ordinates, we have to multiply it by 2, and it is 1 upon 12 multiplied by the sum of the products. You are given 3 ordinates, semi-ordinates, and you have to find the area between the 2 consecutive semi-ordinates or ordinates. The very first multiplier, the very first ordinate will take the very first multiplier. So if you are using E, D and C, the very first ordinate is E, which will take the multiplier 5. The middle one will take 8 and the last one will take -1. In this case, the last ordinate was C, hence you have the multiplier -1. The first ordinate is E, and hence you have the multiplier 5. Whereas in the picture on the right, in the drawing on the right, you have the first ordinate is D, and the multiplier therefore is 5. The last semi-ordinate is F, and therefore the multiplier is -1. This has to be borne in mind, please. What if we have got full ordinates? The same rules apply. You have to find the area between C and D. The first ordinate is D. The last ordinate is B. The first ordinate gets the multiplier 5 and the last ordinate gets the multiplier -1. The middle one is 8. Picture on the right, we are finding the area between B, C and D, and here we have the first ordinate, that is B, hence the multiplier is 5. The last ordinate is D, and hence the multiplier is -1. Now there is another rule called the trapezoidal rule for areas and volumes. Let us say you have 7 half ordinates, thus giving us 6 sections, and each of these half ordinates are h meters apart. Or for that matter, let us take 7 full ordinates, A, B, C, D, E, F and G. Each of these ordinates are h meters apart. The formula, the trapezoidal rule formula is, whether you're using full ordinates or half ordinates, all you have to remember is that if you're using half ordinates, you have to multiply it by 2, but if you're using full ordinates, you do not have to multiply the result by 2. The formula is h multiplied by A upon 2, that is half of A, plus B plus C plus D plus E plus whatever, as many number of ordinates you have, and the final one will also be half of Z. You can have it for any number of odd or even ordinates. Here we have to remember that the first ordinate is halved and the last ordinate is also halved, and the rest in between are taken just as they are. There is no other multiplier except 1. Now here I would like to bring to your attention, that is, for these areas and volumes which are spaced h meters apart, if this h is reduced to as small as is possible, then your accuracy of calculating areas and volumes will be higher. The smaller the h, greater the accuracy. It is a point to note. Do give a thumbs up, do subscribe to my channel, as well as click on the bell icon to get an instant indication for all new postings in my channel. Thank you and goodbye.